Hi students. Okay, today we are going to discuss the topic from polynomials, the algebraic identities. Okay, algebraic identities. These are the formulae which you came across in 8th standard also. So here, how can we use these algebraic identities to expand or to factorize? So those kind of sums we are going to discuss. So before going to that, just let me revise the identities what you guys studied in your 8th standard. X plus y whole square. X plus y whole square is nothing but you might have you remember in the last year we have a plus b whole square. Same formula. We just replaced the x and y in the place of a and b. That's all. Okay. So x plus y whole square equal to x square plus 2xy plus y square. Similarly, x minus y whole square equal to x square minus 2xy plus y square. Next, what is the next identity? X square minus y square equal to x plus y into x minus y. Next, x plus a into x plus b, which is equal to x square plus a plus b into x plus ab. Here, for this, I'll just give an example. Let's take an example. X plus 3 into vx plus 4. Okay? X plus 3 into x plus 4. Here, when you compare this identity with the problem what I had taken, so here you just observe a and b values. Okay, if you observe what is the a value there, compare a value will be 3 and b value will be 4. Correct? So a value is 3 and b value is 4. So what is the formula we have? X square. Okay, so x square plus a plus b. See, x so didn't change. X and x, we have the same x terms here, x here. But in the place of a, we have 3. In the place of b, we have 4. Isn't it? So only the a value and b value, we will take it as 3 and 4. X is as it is. So don't change x value there. That you should remember. You are not supposed to change the x value, whereas you can change a and b, like you can take as a and b value. See, it may be 5, it may be 6, anything, but x remains same. Okay? In this particular sum, a value is, just compare, a value is 3 and b value is 4. So x square, got it, x into x square plus a plus b. What is the next term we have? A plus b into x. What is a here? A is 3, b is 4 into x. Correct? A plus b into x plus a into b. What is a into b here? 3 into 4. So here ab is 3 into 4. So what do you get? X square plus 4 plus 3, 7. 7x plus 4 into 3, 12. So what is the answer you got? X square plus 7x plus 12. I'll just repeat this once again. See what exactly I'm doing. How these identities are useful to solve the problems. That is how these identities you should remember, and you have to by heart or you can practice it or anything, whichever the way you can memorize these identities. Whichever the way you can, that way you can choose and you can memorize. And these are very important where we use this in your next level classes like 10th standard and even your 11th and 12th standard also. This will be like this basic identities you are going to use. So obviously you have to remember this. So now why these sums, why these identities are useful? Where do we use this? So we use this kind of sums in these kind of sums. Actually, the same answer x square plus 7x plus 12 you will get by multiplication also. It means what? Multiplying this term with this term by term multiplication. If you do, at last you will be left with the same answer. Instead of doing that multiplication, means to reduce the complexity. To reduce the complexity. So what we are doing, we are just using this formula. So when you use this formula, it might take 1 hour. It not 1 hour. It might take 2 minutes or maximum 5 minutes to do that. Okay, take it as 3 minutes, so you can get it in 1 minute. So this is how this algebraic identities will help you. So basically what I did, just I compared the sum with the identity, which is there x plus a into x plus b. Whereas here when you compare, a value we got it as 3 and b value is 2. Just you compare. In the place of a we have 3, in the place of b we have 4. So now just use the identity. What is the first term? X square. So x square written. What is the next term? A plus b, which is 3 plus 4. Yeah. 3 plus 4 into x plus a into b, which is 3 into 4. Alright, so x square, 4 plus 3, 7, 7x plus 4 into 3, 12. That's all. That's all. Just you substitute and you will get the answer directly. Okay? I hope you understood that. This is just an example for, like to explain the identity I used. Okay? And same kind of sums you have in your homeworks, like in your textbook. I will just, send it as a homework so that will help you to, practice. So, evaluate, yeah, see this sum, this is, the question is evaluate 105 into 106 without multiplying directly. The question, you carefully look at the question. Here, their intention of the, sum when you look at, you should not multiply. Even you can multiply and get it, but they clearly specify that you should not multiply. So, if not multiplication, what we can do? Correct. So here you should think we should just use identities. So how do we use identities in this case? So I'm writing 105 into 106. See, can I write 105 as 100 plus 5? Got it? Can we write it as 100 plus 5? Okay. Now, can I write this as 100 plus 6? Any doubt, let me know. What I'm doing, I'm writing 105, this means 105, as 100 plus 5 into 106 as 100 plus 6. Can I write or not? It is possible because 106 is obviously 100 plus 6 and 105 is obviously 100 plus 5. So then what I'm doing here, 100 plus 5 into 100 plus 6. Here, which identity can I use there? If you think, you can understand this is nothing but x plus a into x plus b. Yes or no? You just observe this value, so not changed. So this is x itself. See here also x value being changed. X is x itself. Here x is there, here also x is there. So if you compare, this value is same, isn't it? And here a, b. See, these two are different values. Correct? So that is the reason this I can take it as a, this I can take it as b. What? Then once you assume like that, you just write it off. Otherwise, you will be getting a confusion. What will be x, a, b? So x is confirmed, it is 100. And a is 5 and a is 6. Got it? X is 100, a is 5 and b is 6. Okay? So remember how to take it. Which identity can be used? So depends on that, you have to convert the given numbers. Remember, and always choose an easier way, because your simplification should not be more. Your simplification work should be less. That is called a smart work. So always you should go in a way where you can get the answer easily. Which identity is obviously suitable for that? Like that you have to go. So now 100 plus 5 into 100 plus 8, which is same as x plus a into x plus b. So what is the answer, identity for that? X plus x square plus a plus b into x plus ab, correct? So what is the x value? Just substitution, that's all. X value is 100, so 100 square. Correct? Plus a plus b, it means 5 plus 6 into x, which is 100. Correct? Just what I'm doing, wherever x is there, a and b are there, I'm just substituting into plus 5 into 6. What is 100 square? 100 square will be, I know, 100 square you can easily tell. 100 square in the sense what? 2 more zeros will get added, that's all. So it becomes 10,000, isn't it? And 5 plus 6, how much? 11. 11 into 100. 1100 plus 30. Got it? So now you add it, what do you get? 10,000, 1130. See, 10,000, 1130. Isn't it? You want me to add it and show? I hope you can understand the addition. 10,000, 1130. So, which is, okay, 11,130. Okay, you got it. Fine. I'll just explain this once again. So the question was, evaluate 105 into 106 without multiplying directly. They, like in the sum clearly specified, some people what they'll think, they will not even read the sum. Just they will see that 105 into 106 and they just multiply and they'll get the answer. Means just you think, you are not in some, second standard or first standard, they give direct multiplication. Obviously, they will not give. So obviously you should think, evaluate without multiplication, without multiplying directly. They clearly specified you should not multiply directly. So what we are doing here, we are just taking 105 into 106 and 105 I can write it as 100 plus 5. Correct? Similarly, 106 I can write it as 100 plus 6. Got it? So now, in these 4 identities, which identity is suitable for that? Which can be applied over there? So in that case, if you check all those identities, that comes under x plus a into x plus b. Because these 3 identities we cannot use. Obviously, there is no whole square here. There is no square minus square. Obviously, x square minus y square you cannot use. So that is the reason I can use only the last identity which I wrote, x plus a into x plus b, which is equal to x square plus a plus b into x plus ab. So what I did, I just written 105 is 100 plus 5, 100 plus 6 is 106, and I had taken here 100, 100, x, so constant which is x, means the value which is for x is 100. And what is a here? First value is a and second value b. So write like this so that you will not get confused. Once you write like this, just apply in the formula. X square plus a plus b into x plus ab. So x square, what is x? We have taken 100. So 100 square plus a plus b, 5 plus 6. So 5 plus 6 into 100 plus ab, which is 5 into 6. Got it? So now 100 square is 10,000 plus 6 plus 5, 100. So sorry, 6 plus 5, 11. 11 into 100, which will be 1100 plus 6 into 5, 30. So what I did, I just added all these 3. Okay, 10,000, 1100 and 30, which will give you, okay, I think it is 1100, right? Yeah, 10,000, 1100, which will give you 11,130. Correct? 11,130. I think it should be 11,130. So 0, 3, 1. So again 1. I think you observe 10,000. I added clearly 10,000, 1100. See properly. I am writing in the place of hundreds, thousands also. So 30. So if you add all those things, obviously you will get 1100, 130. Got it? 11,130. So that will be your answer. 11,130. So I hope you can do this kind of sums and you understood this sum. Okay? Okay, fine. Next, we will go with the next sum, which is 49a square plus 70ab plus 25 square. Factorize. And factorize, maybe in the last class also I discussed the factorization part. Anyway, this is not that kind of factorization what we did middle term expansion. We are not splitting the middle term here. What we are doing, we are just applying or converting this whatever the terms they're given into the respective identity. So how do we convert? First one, let me take 49a square plus 70ab plus 25b square. This is the identity, this is the sum given. So now you should use your brain, obviously. When you compare that with these any identities, you can observe maybe they just changed x and y. Just observe here x square, there what it is, a square. Here there ab, here x into y. There 25b square, here y square. Some, similarity you're able to see there, isn't it? That similarity you cannot see in the other three identities. Are you understanding? Here it is same, but minus is there, plus is there. So obviously this is that sum is not related to these three identities. It is related to first identity. So how can we convert that in terms of this first identity? So, and we know that identities are nothing but LHS is equal to RHS. It means if you get this, you can write this. If this can be written as like this. So both the ways it is correct. It means like A is equal to 2 is nothing but 2 is equal to A. Isn't it? If A value is 2, it doesn't mean 2 value is A. Correct? So both are same. If you write A is equal to 2, that is also correct. If 2 is equal to A, that is also correct. There is no, nothing wrong in that. So similarly, if this is equal to this, and this should be equal to that, obviously. Okay? Understood now? 49a square plus 70ab plus 25b square. 49a square. 49 is a perfect square. Correct? And everybody knows that 7 square is 49. So what I'll write? 49a square, I'll write it as 7a whole square. I'll write 49a square as 7a whole square plus let me write for 5. So can I write this 25? Again 25 is also is a perfect square. 5 square is 25. So can't we write it as 5a whole square? So now what is missing here? The middle one, 70ab. So how can we write 70ab? So here 2 should be a multiple. So 2 you write. Understood? See, it is very simple. When you came to know which is x, so now we came to know what is x, right? See, x whole square, x square. So x value is 7a. Just use your brain. Can you write that as 7a whole square? Here x whole square. So x value we got, and y square. So 5b whole square, and here y square. So y value we got. What is x here? X is 7a. Y is 5b. Correct? So if that is the case, okay, so 2 into x into y, just you substitute. X is 7a, y is 5b. You multiply 2 into 7a into 5b, obviously you will get 70ab. So your work, first you find out x and y. So your work becomes simple. Understood? So you can easily write 70ab as 2ab, like 2xy. So basically what I am telling, when you find 7a as 7a and 5b as x and y, so obviously that is 2 times of x and y, which is 2 into 7a into 5b. You just multiply and check, you will get 70ab or not. Obviously you will get, because 7 into 5 is 35, 35 into 2 is 70, a into b. Okay, so now if you compare this with this, obviously you got x value as 7a and y value as 5b. So what is the LHS for that? X plus y whole square, which implies 7a plus 5b whole square. That's all. So your work is completed. You just written it in the simpler form and we factorize it. Got it? Okay, I'll just explain this once again. First one is we have to factorize 49a square plus 70ab plus 25b square. Okay. So now what I am just comparing that given sum with these identities what I wrote. So when I compare that sum with identities, you just check for all are, first thing is all are of positive sign. So here you tell all are of positive is only in this and the last one. Correct? Fine. Now here square is there at last, the square is there at first. That is there only for first one. So then obviously this sum is related to first identity. You can think like that. Okay. Now after doing that, obviously this is x whole square. So means one term should be there here, not more than one term. So, and we know that, and remember, if you want to convert or conversion kind of problems, max to max, they will give a perfect square only. So, can I convert this 49a whole square as 7a whole square? Can we do that? Yes, because 7 square is 49a square. Correct? So, which will give you 49a. So, 49a square I am writing it as, converting it as 7a whole square. And now 5b square is it, means 25b square. 25b square can be written as, I'll write and here and show here, I'll just write and show. 25b square can be written as 5 square into b square. Got it? So 5 square into b square, square is same, right? We know that a power n, b power n can be written as ab whole power n. You can remember this formula if you have any confusion. AB whole power n can be written as a power n into b power n can be written as AB whole power n. So can't you write it as 5 square into b square? Can't we write it as 5b whole square? Because the power is same. Similarly, I written like. Similarly, I wrote for 7a square also. Okay, so now this is in the form of a means x square plus, see here, we got x square. So we written 7a whole square. That means we got x value. The square same, x is 7a. Similarly, y square, 5b whole square. So y value is 5b. So, and obviously what is this 70ab? You can write obviously 2xy, you just substitute, that's all. 2xy should be there. So 2 is 2 as it is, you write. X we are taken, 7a, b are taken, y are taken 5b. Just write it. So obviously it will be equal to 70ab. Okay, it is equal. Understood. So you can just cross check it. 5, 7 is 35, 35 is 70. It will come equal. Don't worry about it. So a square plus x square plus 2xy plus y square. What is the formula we have? X plus y whole square, which is 7a plus 5b whole square. So we converted that as a 7a plus 5b. This is the simplest form. Got it? Okay, yeah. Next we will, I consider the next sum, 25 by 4x square minus y square by 7. 7, let me check, it is 9 actually, y square by 9. Okay, 25 by 4x square minus y square by 9. So, again here, which identity can be used? Okay, so which identity is possible? Just check in these 4 identities which have both squares. Got it? This is whole square, this is whole square, this is x plus a into 2 terms are there. So which identity is suitable? Suitable to do factorization for that, which is x square minus y square. So how can you apply? Again I told we have perfect squares here. When you have perfect squares, so what we have, even x is also square, y is also square. This 25 by 4 x square minus y square by 9. So 25 by 4 can be written as 5 by 2 and x whole square. Correct? Because 25 by 4, actually 25 by 4 can be written as 5 square by 2 square and x is already squared. Got it? Everywhere we have common exponent. So what I can write? 52, 5 by 2x whole square I can write. Because when you send the square inside, even 5 also squared, 2 also squared, x also squared. So you'll get the same thing. Isn't it? Can't we write like that? So we have written 25 by 4x square means what I did, I just kept this square separately. Whereas the term inside the square, because it should be in the form of x square. It means we don't have more than x, only one term is there. So I am making the 25 by 4x square as one term to the square, one term whole square. So that is the reason I just converted 25 as 5 square, and 4 as 2 square, again x square. We can also write it as 5 by 2 x square. Similarly, how can you write this y square by 9? Just check it out. Y square by 9 can be written as y square by 3 square. Obviously 9 is the perfect square, which is 3 into 3. So y square by 3 square can also be written as y by 3 whole square. Correct? So we can write it as y by 3 whole square. So write that as y by 3 whole square. Got it? So now you just find which is x and which is y. Square, so there also there. Here also square is there. Here also we have square. There also square. Here also square. Which is matching with x and y. Which is in the place of x and y. In the place of x, we have 5 by 2x. Correct? If you compare this exactly with that, in the place of x, we have 5 by 2x. In the place of y, we have y by 3. Isn't it? In the place of y, we have y by 3. See, your 90% of sum is solved when you find x and y. It will be solved. Once you find the x and y, it is easy to just substitute. Your main intention or your main thing, what you have to focus on is you have to find x and y. So what is x and what is y? That is only the main thing which you have to focus upon. Understood? Focus on. So x is equal to 5 by 2x and y is equal to y by 3. So what is the formula for x square minus y square? X plus y into x minus y. So just use that formula. X plus y. It means 5 by 2x plus y by 3. Next, x minus y. 5 by 2x minus y by 3. That's how. This is the factorization of the given sum. Okay? I'll just explain you once again. What is the given sum? 25 by 4x square minus y square by 9. So always whenever they give these kind of sums, factorize kind of sums, just you remember all the identities, because we have to by heart this or to practice and keep in your mind. Understood? These identities, they will not give in the exam. You should remember. Okay? You should remember all the identities and you should get an idea that which identity can be used over there. So when you compare that with these identities, it is matching with third one, because x square, y square, they are also square. So but what is missing in that is, it is 25 by 4 x square, but one term whole square we need. One term should be there inside the as an base and exponent should be 2. So that is how we have to convert. So what I did, as they given 25 by 4, so 5 and 4 are the perfect squares. Can't we write it as 5 square by 2 square into x square? The whole thing we can write it as 5 by 2x whole square. You just send the square inside, you will get the same thing. 5 square by 2 square into x square, you will get the same 25 by 4x square. So that's the reason I written 5 by 2x whole square minus. Similarly, y square by 9, can't we write it as y by 3 whole square? Again, 9 is a perfect square, which is 3 square. So I'm writing it as y by 3 whole square. If you again if you send square inside, you'll get y square by 9. So which comes under the formula? See, now you check x square, one term only is there as a base. There also y by 3. So I'll just write it as x is equal to 5 by 2x and y value is y by 3. So what is the formula we have? X plus y into x minus. Just add it. 5 by 2x plus y by 3, x plus y. So 5 by 2x plus y by 3 into 5 by 2x minus y by 3. Okay? I hope you understood this. Thank you very much, children. Please share, comment and subscribe to our channel. Be healthy, be safe.